In section 5.3, we're going to be looking at a very particular discrete probability distribution called the binomial distribution. Before we talk about the binomial distribution, I have a quiz I want you to take. Choose your best guess for the following 5 questions. Do not cheat. It's just important that you do your best. Give yourself about 5 minutes, it should not take long, and answer questions 1 through 5. Pause the video. When you resume, we'll talk about it. All right, did you answer the quiz? Great. Hopefully you thought it was a little difficult. It's intended to be difficult. It's intended to be questions that you wouldn't know the answer to and that you would be forced to guess. Okay, if you read these questions, you can see they're extremely specific and very highly unlikely that you even knew the answers. The intention with this quiz was just to get you to guess, randomly guess what the answers are. And by randomly guessing, we have a probability experiment. So let's go through the correct answers for the quiz. Number 1 is D, number 2 is A, number 3 is B, number 4 is C, and number 5 is B. Now that you have the correct answers, count your number of correct answers. Let your number of correct answers be X. We're going to come back to these questions after we discuss our definitions. So let's talk about the binomial distribution. Many types of probability problems have only 2 possible outcomes, or they can be reduced to 2 possible outcomes. Some examples: when a coin is tossed, it can land on heads or tails. When you buy a lottery ticket, you either win or lose. When you take a class, you pass it or you don't. And there are tons more examples. The very thing we just did. When you take a quiz, you get a question right or wrong. A binomial experiment is a probability experiment that satisfies the following requirements. Each trial can have only 2 possible outcomes. We identify these outcomes using the words success or failure. There must be a fixed number of trials. The outcomes of each trial must be independent of each other, and the probability of success must remain the same for each trial. Putting this into the framework of our quiz that we just took, the quiz is a binomial experiment because for each question, we can be right or wrong. We only have 5 questions. That's a fixed number of trials. The outcomes of each trial are independent. My choice for question 1 does not affect my choice for question 2 or 3, etc. And the probability of success must remain the same for each trial. Each question had 4 answers, and only 1 answer was correct. So our probability of a success would be 1/4. Why do we call it a binomial experiment? Just like for bicycle meaning 2 wheels, binomial means 2. I'll give you one more example that on the surface may not seem like a binomial experiment, but we can reframe it so that it is. And that one more example is rolling a 6-sided die. Notice we can reduce this to 2 outcomes by saying you roll a 4 or not a 4, or you roll odd or even, or some other combination. Less than 3, greater than or equal to 3. As long as we can take the experiment and break the outcomes into 2 possible outcomes. In the rolling of a die, it has 6 outcomes, but we can group them together in certain ways to end up with only 2 outcomes. The binomial experiment leads to a binomial distribution. We have this binomial experiment that we can repeat that satisfies all of these 4 requirements. But if we consider all of the different possible situations of the binomial experiment, we can form a binomial distribution, a probability distribution, based off of that information. We get some notation with a binomial distribution. P of S is the probability of success, and P of F is the probability of failure. P and Q are just the numerical probabilities of success and failure. So really, P of S, being the symbol for the probability, will be equal to the number P. And P of F, the symbol of the probability of failure, will be equal to the numerical value Q. Also pointing out that P and Q, if we add them together, we're going to get 1. N is our number of trials. So for our quiz, we had 5 questions. N would be 5. X is the number of successes in all of those trials. So one trial is one instance of the experiment, but the experiment can last over several different number of trials, and that N is our number of trials. In practice, we don't use P of S and P of F very much, but I wanted to make sure that you were aware that that's what they stood for. Also, this notion of success and failure is not tied to the actual definitions of success and failure. Success can be what quality we want from the probability distribution, and failure is what we don't want. Just be a little careful with the idea of success and failure. Don't be tied to their English meanings, because it may not be the case. So X can take on the values 0 up through N. So we can say that X is between 0 and N inclusive. And then to calculate the probability for a binomial distribution, we have a formula that we're not going to be using much by hand. We're going to be tapping into technology. These numbers can get pretty cumbersome pretty quickly. In a binomial experiment, the probability of exactly X successes in N trials, and this N is really the same kind of N as before. We'll make our notation stay the same. These are capital N's. In a binomial experiment, the probability of exactly X successes in N trials is given by this formula, where this part of the formula should look a little bit familiar because this is our combinations. This piece is our formula for combinations, n factorial divided by n minus x factorial. We were using n's and r's, but it's the same formula. We just replaced the r's with x's. And then the second part of the formula is the p of x times q of n minus x. The P of X is my probability of successes. So how many successes did I have? Probability of that. Q to the power N minus X is my probability of failures. So we could look at this in the context of our quiz from before. The 5-question quiz, our probability of success was 1 out of 4. We had 1 correct answer out of 4 possible answers. Our probability for failure is 3/4, 3 wrong answers out of 4. Notice that 1/4 plus 3/4 will give me 1. Also, I had n equals to 5 because I had 5 total questions. If I wanted to know the probability that I got 3 questions correct, this means that x would equal 3 because x is the number of successes. I want to know what the probability of getting 3 correct is. I could use this formula and plug these numbers in. And once I plug the numbers in, I can simplify, use my calculator, and get an answer. Let's try to simplify some of it by hand first so that it makes it a little easier to plug in. So for 5 combination 3, we get 10. 1/4 to the 3rd power and we can multiply, use the exponents. And so now that I've found these numbers, I'm going to multiply them. And we get 0.08 0.078, so 0.088 for our probability, which is about 8.8%, that we get 3 questions right on a 5-question quiz if we're guessing randomly. In the next part of the lesson, we'll take a look at formulas used in Google and Excel, and then apply those to some examples.